Balancing chemical equations is essential for general chemistry. And so here are two different examples for how to balance chemical equations. So in the first one, we have TiCl4, liquid, added to water, which is also a liquid, and we got solid titanium dioxide and hydrochloric acid out of that. So the question is, are these balanced? So the first thing we're going to do is write down what we have on both sides of our chemical equation. My preferred preference is to write down each individual group on both sides. Here's a tip, make sure they're the same, otherwise when you balance them, it requires just a little bit more effort to make sure that the titaniums are both balanced. This way you essentially make a little chart. So on both sides, or on the left, we have 1 titanium, 4 chlorines, 2 hydrogens, 1 oxygen. On the right, we have 1 titanium, 2 oxygens. We have only 1 hydrogen, and we only have 1 chlorine. So the question is, where do we begin? So the first thing I would suggest is that we start with something that's perhaps the highest imbalance. So we could start with the hydrogens or the oxygens. Either of those would probably be fine. But we're going to start with the chlorine. And so we're going to put a 4 in front of the HCl. So when we do that, now we have 4 chlorines. We also have 4 hydrogens. So in order to balance this on the other side, we need to put a 2 in front of the water. Okay, so when we do this, we now have 2 by 2 is a 4 hydrogen. We also have 2 oxygens. So we now have 2 things that match. So the chlorines are both identical as well as the hydrogens. Well, let's double check everything else. We still, on the right and the left, have 1 titanium. We haven't added a stoichiometric coefficient there. And for the oxygens, we were imbalanced, but with the coefficients we've added, we now have a balanced chemical equation. We always want to rewrite our balanced chemical equation. Just to make sure that we got everything right. We don't lose something in the paper. So as you can see, we now have a balanced chemical equation. So in this case, it's a combustion reaction. And so one thing we need to know is we don't actually have any products, but the products of a combustion reaction, which is something flammable plus oxygen, are CO2 and water. So we're going to have H2O and CO2. So this is a little different, and there are only 3 entities on both sides. And so we want to create another table. So on the left, we have 3 oxygens, we have 6 hydrogens, and we have 5 carbons. On the right, we have 1 carbon, 3 oxygens, and 2 hydrogens. So we could either choose to balance the hydrogens first or the carbons. Either one will be fine, but in this case, let's go ahead and look at the carbons. So we're going to put a 5 here. When we do that, we have 5 carbons. So we're actually going to go ahead and balance the hydrogens, or attempt to do that at the same time, because we can have our 6 on the left give us just 2 on the right, so we can multiply. We can put a 3 here, which will give us 6, and this way we can total up our oxygens. So we have 3 plus 10, which gives us 13. So when we go back to the right side, 13 and 3 doesn't really work. So we can add a 6 here, which would give us 12 plus 1. And so now we do have 13. So that looks like a balanced chemical equation. So let's write it out and double check. So we've C5H6O plus 6O2. It's a gas, it's a liquid. It's going to give us 3H2O, which in this case is going to be a liquid, plus CO2, 5CO2 gas. Let's just do a quick double check. 5 carbons, 5 carbons, 6 hydrogens, 6 hydrogens. We have 3 plus 10 is 13, and 12 plus 1 is 13. So we have a balanced chemical equation on both sides.